Robots designed for war? AI is pushing boundaries like never before, and tech companies are diving deeper into defense. Things are escalating fast, and the developments are nothing short of astonishing. From a humanoid war machine making its first public appearance in a San Francisco nightclub to AI research agents that can replace hours of work in minutes, there's a lot to discuss. Let's start with something unexpected. A humanoid war machine making its debut, not on a battlefield, but inside a San Francisco nightclub. That's exactly what happened when the Phantom MK1 robot took the stage at Temple nightclub during what was called the quarter-of-the-century tech gigaparty. This robot, built by a startup called Robotics Labs, left quite an impression. At the event, attendees saw Phantom MK1 on stage, DJing. Robotics Labs, the company behind this machine, was founded in 2024 and secured around $11 million in seed funding. The company's founder, Sankey Pathak, previously ran a fintech startup called Synapse, a banking-as-a-service platform that eventually went bankrupt. After that, he shifted his focus entirely to robotics. His co-founder, Mike LeBlanc, is a former U.S. Marine and co-founder of a security robotics company called Cobalt AI. Together, they're working to develop humanoid robots capable of handling a wide range of tasks, from industrial work to full-scale military applications. Unlike many companies that avoid discussing military uses, Robotics Labs is open about its defense ambitions. Pathak has spoken publicly about the importance of keeping up with China's advancements in defense robotics, emphasizing that advanced humanoids could play a key role in future warfare. According to an SF Gate reporter, Phantom MK1 is essentially a war machine. But does it really live up to that title? Let's look at the specs. Phantom MK1 stands at 1.75 meters, about 5 feet 9 inches, and weighs approximately 80 kilograms, 175 pounds. It can lift up to a 20 kilogram, 44-pound payload. Under the hood, it features advanced cycloid actuators, which, according to Foundation, combine the power of hydraulics with the efficiency and quietness of electric motors. This means the MK1 can deliver a peak torque of around 160 Newton-meters while maintaining a back-driving torque of under a single Newton-meter. In simpler terms, it has both strength and precision. Robotics Labs envisions this robot performing general-purpose tasks, ranging from industrial work and home services to entertainment, and, if necessary, combat roles on the battlefield. Phantom MK1's upper torso acts as its central command, housing batteries, processors, cameras, and sensors that provide 360-degree situational awareness. The company is also highlighting its lower torso, designed for balance and movement, allowing it to navigate uneven terrain, climb stairs, and operate in confined spaces. It has been engineered to have a human-like gait, making it suitable for factories, offices, and disaster areas originally designed for people. Interestingly, Phantom MK1's core platform is built on technology acquired from Boardwalk Robotics, a small Florida-based company that introduced a humanoid robot named Alex in August 2024. Alex relied on a stable base for performing advanced manipulation tasks, but Phantom takes things to the next level with a more sophisticated lower torso and enhanced mobility. Robotics Labs has ambitious plans. They aim to ship over 40 robots in 2025, scale up to 10,000 in 2026, and exceed 20,000 by 2027. Their goal is to reach $1 billion in annual recurring revenue, which is a massive target for a startup that was founded just a year ago. And they're thinking even bigger, using those profits to establish a base in Antarctica and eventually expand operations to the Moon, Mars, and beyond. It's a bold vision, and it aligns with a growing trend where more tech companies are becoming comfortable with defense applications. Even major players like Meta, OpenAI, and Google have started shifting their stance on military contracts. This shift might remind you of Boston Dynamics, which worked with DARPA to develop a humanoid robot called Petman for the U.S. Army in 2011 to test chemical protective suits. Then there was Atlas, originally funded by DARPA, designed for disaster response but later repurposed for industrial applications under Boston Dynamics, now owned by Hyundai. Russia also entered the humanoid robotics race in 2016 with a robot named Fedor, originally intended for space missions but later revealed to have firearm capabilities. So the concept of military humanoid robots isn't new, it's just accelerating. Switching gears to AI and robotics research, a major collaboration between Nvidia and Carnegie Mellon University has led to the development of a framework called ASAP, which stands for Aligning Simulation and Real Physics. The idea is to train robots in virtual environments where they can push their limits without real-world risks. Then, ASAP ensures that the skills learned in simulations translate effectively to real-world conditions. ASAP has been shown to reduce motion errors by about 53% compared to older methods. In tests, a G1 humanoid robot trained with ASAP successfully performed forward jumps over a meter in distance, an impressive feat for a humanoid. However, the team did encounter some hardware challenges. They pushed the G1 robot to its limits, so much so that some of its motors overheated, causing damage to 2 test units. Despite this setback, researchers remain optimistic, viewing these failures as opportunities to refine the hardware. To accelerate innovation, they've even made their code open source on GitHub, allowing scientists and developers worldwide to build on their work. In another major development, the same G1 robot was used to test a new humanoid motion framework that enables it to sit, roll, and stabilize itself using its entire body instead of relying solely on a bipedal stance. Traditional humanoid control methods struggle with random physical contacts, like when a knee or elbow accidentally touches the ground. However, this new approach leverages a GPU-accelerated rigid body simulator, allowing the robot to handle unpredictable interactions in real time. This advancement means the robot can adapt instantly to uneven surfaces, recover from falls, and perform highly human-like movements that older models simply couldn't manage. The goal is to create dynamic motion capabilities that closely mimic human agility. Now, let's shift focus to another company making waves in the humanoid robotics space, PND Robotics, the creators of Adam. This company, sometimes spelled as PND in certain references, has been showcasing Adam's precision and dexterity by having it perform calligraphy and other intricate tasks that demand fine motor control. Building Adam is no small feat. It takes approximately 37 hours of production, involving complex 3D modeling, CNC machining, and assembly. The robot boasts 37 degrees of freedom and is powered by 20 actuators, enabling it to perform a wide range of delicate movements. Adam's control system, known as the PND PMC system, synchronizes 163 CNC machined components and nearly 400 3D printed parts. The company uses 7 different composite materials and 13 specialized manufacturing processes, all handled in-house, resulting in a highly durable humanoid capable of precision tasks like tool assembly and object balancing. One of P&D Robotics' biggest innovations is its imitation learning framework. This allows Adam to learn locomotion by analyzing human movement data, leading to significantly more natural and agile motion compared to the stiff, mechanical walking patterns seen in older humanoid models. It's clear that robotics is advancing at an incredible pace. Foundation Robotics Labs is tackling labor shortages and moving aggressively into defense with Phantom MK1, aiming to create humanoids capable of performing nearly any task, including warfare. Meanwhile, Carnegie Mellon and Nvidia are bridging the gap between virtual training and real-world execution, making AI-driven robots more adaptable than ever. And then there's P&D's Adam, demonstrating remarkable dexterity with advanced imitation learning. On the software side, OpenAI and Google are locked in a competition to develop the most powerful autonomous research agents. With each breakthrough, the race toward a future dominated by AI-driven humanoids is accelerating faster than anyone could have imagined. Honestly, it's both fascinating and a little unsettling to picture a future where humanoid robots seamlessly operate in factories, handle delicate materials, or even guard remote outposts in Antarctica, all while AI agents feed them real-time data to optimize their tasks. Whether this is the next step in human innovation or a path toward a dystopian future, one thing is certain: it's happening fast. Thanks for sticking with me on this deep dive. If you found this interesting, don't forget to hit the like button and subscribe for more updates on cutting-edge robotics and AI breakthroughs. We've only scratched the surface of what's possible, and the future looks more exciting and unpredictable than ever. See you in the next one.